Resources are the basic building blocks of Puppet. We'll look into basic built-in resource types and custom types provided by modules. Before getting into particulars, it's important to understand that Puppet is a tool for defining and implementing a desired state on your nodes. Desired state is really a core concept of how Puppet works, but it's also very easy to get wrong. Writing Puppet code is not describing a process or a series of steps that you'd like to take. It's defining the final desired state. Puppet itself will figure out the process. This may seem obvious, but I want to point it out now because if you think of Puppet as just another scripting language, you'll end up writing terrible Puppet code. You'll really be missing out on how powerful Puppet can be if you approach it from that perspective. Just remember that the Puppet language is primarily a method for describing the desired state of your infrastructure. It's essentially a modeling language that Puppet uses internally to create a model of your system and then makes the system match that state. Resources are the individual units of Puppet configuration, the individual building blocks that Puppet uses to develop the model of your system state. In Puppet, you're describing the desired state you'd like your systems to be in, and you do that by specifying the state of specific resources. There are a lot of built-in resource types, including common ones like user, file, package, and service. Most of them are pretty intuitive. For example, you tell Puppet that you want a particular package installed on a system. When Puppet runs, it checks if that package is already installed and installs it if need be. That behavior, only changing something if it isn't in the desired state, is called idempotency. It's a term borrowed from mathematics, but you'll hear it a lot in reference to Puppet. To understand the concept, let's use the analogy of doing the dishes. Say it's your responsibility in your household to make sure that the dishes are done every day. So sometime before you go to bed, you follow a step-by-step procedure. You go over to the sink, you fill it with water and add soap, and wash and dry any dishes that need to be done, and then drain the sink. But what happens if you go out to eat so there aren't any dishes to be washed? Do you go over to the sink and fill it with water and add soap and wash and dry 0 dishes and then drain the sink? Of course not. Your step-by-step task of doing the dishes is really the idempotent, ensure the dishes are done. Exec is a very commonly used resource type. It allows you to run arbitrary code on a system being managed by Puppet. So it's both flexible and powerful. Unfortunately, it's often misused to make Puppet act more like a scripting language than a modeling language. This is really rooted in a fundamental misunderstanding of what an exec is. From Puppet's perspective, an exec is just another resource. So when you're writing an exec, first ask yourself, what state is this exec creating? And how can I check if that state already exists? Imagine that you're managing a web server node, and you have a script that downloads and installs a specific version of a custom web app from a local file server. For whatever reason, this particular script doesn't use the operating system's package management. You could use an exec to run that script, but you're still missing an important piece. What's the desired state in this case? Version X of the package is installed on the node. So let's imagine the same script has a feature that will tell you what version of the app is currently installed. A good exec should always include a check to see if the desired state already exists. That way, Puppet can fit the exec into its model and make it idempotent. Think of that check as changing it from a step in a procedural script to a thing that can be managed. In addition to the many built-in resource types, it's also simple to define new resource types. These are just made up of other resources. So if your DevOps team needs to be able to log into every system via SSH in order to respond to emergencies, you might define an admin user type that included a system user, SSH key, and certain packages installed on a system. That lets your code stay more readable since you can just apply the custom resource to a node. There is a more advanced method for creating custom resources, which is usually referred to as type and providers. This method makes sense for resources that can't be constructed from other existing resource types. For example, someone has created a module with a type and provider to control the state of Philips Hue smart light bulbs by interacting with the Hue API. Every resource has a parameter called a namevar, which is something unique to the target system. For example, for a file, the namevar is a path parameter. For other resource types, it will be something else. If you leave off the name bar, Puppet will use whatever you have set for the title of the resource declaration, which is what we did in the last example. To some degree, this is a matter of personal preference, but there are times when it can be very helpful to reference a resource by a simple human-readable name instead of something like a long file path. Finally, I want to make the note about the trailing comma here. Puppet requires a comma between each parameter and allows a trailing comma after the last one. It's a good habit to always add that trailing comma because it's easy to forget the comma between parameters if you add any later on.